Hi my friends, and welcome back to the You Can Do TV channel. In this video, You Can Do TV takes you on a journey of discovery, from iron ore mining to iron refining and steel plate production, all the way to manufacturing the world's sharpest and hardest knives. We will in turn visit the large steel mill in Australia, the leading steel producer in Italy, and the famous knife factory since 1790 in Germany. At OneSteel, Australia, the steelmaking process begins with the extraction of raw iron ore and processing them into refined iron ore pellets. These pellets are essential raw materials for blast furnaces in the steelmaking industry. Let's find out the details of the steel pellet production process at OneSteel. Iron ore extraction. OneSteel operates open-pit mining operations for iron ore extraction. The company's mining operations in South Australia, particularly in the Middleback Ranges near Whyalla. Crushing and grinding. The extracted iron ore undergoes crushing and grinding processes to reduce its size and increase its surface area, facilitating efficient pelletization. Beneficiation. The crushed and ground iron ore is subjected to beneficiation processes to remove impurities and enhance its iron content. These processes include magnetic separation, flotation, and gravity separation. Pelletizing. The beneficiated iron ore is mixed with a binder, such as bentonite clay or organic binders, to improve pellet strength. The mixture is then pelletized to form small, uniform pellets. Drying. The freshly formed pellets contain moisture and are dried to remove excess water. Drying is crucial for achieving the desired pellet strength and preventing breakage during handling and transportation. Induration. The dried pellets are subjected to high temperatures in an induration furnace. The induration process involves heating the pellets to promote consolidation and strengthen them. The binder reacts and binds the particles together, resulting in durable pellets. Cooling and screening. After induration, the pellets are cooled and screened to remove undersized or oversized pellets, ensuring a uniform size distribution. Storage and dispatch. The final iron ore pellets are stored in silos or stockpiles before being dispatched for further use. Rail or ships are typically used for transportation to steel mills. The manufacturing process at Arium's Whyalla Steelworks begins in the ironmaking department, which includes the coke ovens, blast furnace, and power and services sections. Approximately 1 million ton of coal per year are brought in to be converted into coke, which serves as the primary fuel source for the blast furnace. Inside the furnace, superheated air, coke, iron ore, in the form of lump and pellets, and various fluxes are combined to produce molten iron. The molten iron is then transferred to the steelmaking department, where it undergoes conversion into steel. This transformation occurs at the basic oxygen steelmaking plant, where the carbon and silica content of the molten iron is reduced to produce different grades of steel. The molten steel is subsequently transported to either the billet caster or the continuous slab and bloom caster, where it solidifies through a water cooling process. After solidification, the steel is cut into basic shapes. The slab and bloom caster produces approximately 300,000 tons per year of steel for structural sections and around 100,000 tons for rail sections. Both types of steel are further processed at the Whyalla Steelworks rolling mill complex. The billet caster, on the other hand, can produce around 750,000 tons of billet steel per year, which is used for OneSteel's operations on the east coast of Australia. The billet steel undergoes value-adding processing to manufacture a range of products for customers in industries such as automotive, mining, and reinforcing. The final step in the manufacturing process is carried out in the steel products department, where the steel slabs and blooms are shaped into the final products and dispatched to customers. This department includes the rolling mill, rail finishing end, shapes finishing end, and material handling sections. The Whyalla Steelworks products have been used in the construction of various landmark Australian projects, including the Alice Springs to Darwin Railway, the Melbourne Convention Centre, and the Perth Arena. Franchini Acciai Spa is a leading steel manufacturing company based in Monticelli Brazati, in the district of Brescia, Italy. The production process at Franchini Acciai begins with the selection of premium raw materials. The quality of the ingots is crucial to ensuring excellent forgings. The company optimizes the cutting of ingots into forged parts through a combination of 20 saw cutters and an oxy-fuel cutting machine. This precision cutting process allows for the efficient sizing of the ingots. Forging is the core operation at Franchini Acciai, playing a crucial role in the production of high-quality steel products. The company utilizes 10 furnaces of different volumes, with the largest furnace boasting a capacity of up to 450 cubic meters. These furnaces serve the purpose of heating the ingots, which can be obtained either from Franchini Acciai's own warehousing or directly from steel mills. The ingots are transported in insulated trucks, which enables the practice of hot charging. Hot charging refers to the process of inserting heated ingots into the open die presses for further shaping and processing. The heated ingots are then subjected to various operations within the open die presses. These operations include IPS setting, stretching, punching, and stretching on a mandrel. Franchini Acciai possesses 3 different presses, each with its own capacity: 2,500 tons, 3,500 tons, and 8,000 tons. The presses are equipped with integrated and automated manipulators, which facilitate the handling of forged parts weighing up to an impressive 100 tons. The presence of these advanced manipulators streamlines the production process and ensures efficiency in the handling of heavy and complex forgings. In order to attain the desired mechanical and metallurgical characteristics, Franchini Acciai maintains a state-of-the-art heat treatment department. Within this department, there are furnaces capable of reaching temperatures as high as 1,150 degrees Celsius. These furnaces are equipped with advanced control systems to ensure precise and accurate heat treatment processes. The length of the forged parts that can be accommodated within these furnaces extends up to an impressive 24 meters. Such capabilities allow Franchini Acciai to handle a wide range of forging sizes and meet the diverse needs of its customers. The heat treatment process at Franchini Acciai involves quenching, which is the rapid cooling of the forged parts to enhance their mechanical properties. The company offers flexibility in the choice of quenching medium, which can either be water or polymer-based. This selection depends on the specific requirements of the forged parts and the desired outcome. The department's automatic loading system is a crucial tool that facilitates the simultaneous treatment of multiple pieces, enabling efficient production and precise control over transfer times. Throughout the entire heat treatment process, highly qualified personnel oversee and manage the operations to ensure optimal quality and consistency.
Bitte? Sie möchten, kann ich Sie auch mal mit rausnehmen?
Franchini Acciai's workshop is equipped with computer numerical controlled CNC machines for rough and fine machining of forged parts. These machines include vertical and parallel lathes, milling cutters, boring machines, and drilling machines. The CNC machines ensure precise and efficient machining, meeting the exact specifications of the forged parts. Quality is of utmost importance at Franchini Acciai. Technicians oversee the entire production process, from raw materials to finished parts, to ensure strict compliance with internal procedures and reference standards. Surface quality inspections are performed using magnetic particle and dye penetrant examinations. Internal quality control involves ultrasonic tests, dimensional checks using gauges and templates, and hardness testing using a 3,000 kilogram Brunel hardness tester. At this steel mill, the manufacturing process of steel plates begins with the selection of suitable slabs, which are large rectangular blocks of semi-finished steel obtained from the steelmaking process. The first step is reheating the slabs in a reheating furnace to a precise temperature suitable for hot rolling. This process ensures the slabs become malleable and ready for further processing. Next, the heated slabs are fed into a hot rolling mill, where they pass through a series of rolling stands. These stands gradually reduce the thickness of the slabs while increasing their length and width. The process is known as hot rolling and is carried out in a 4-high reversing rolling mill. The 4-high reversing rolling mill employs a combination of rolls to reduce the thickness of the plates, providing excellent control over the final product's dimensions and surface finish. This process ensures high-quality steel strips with consistent thickness throughout. Thermomechanical control is an essential aspect of the hot strip mill. It involves carefully controlling the temperature and mechanical forces applied during the rolling process, optimizing the material's properties and improving its strength and toughness. To enhance productivity and product quality, accelerated direct cooling and direct quenching methods are employed. These techniques rapidly cool the rolled strips, allowing for precise microstructural control and improved mechanical properties. The manufacturing process of Felix knives, which are produced in Zollingen, Germany, is a meticulous and precise operation that combines traditional craftsmanship with modern techniques. Split. Cutting the raw material. The process begins by cutting the raw material, which is high-quality steel such as chromium, molybdenum, vanadium steel. Forge the knife blank. The raw material is heated to a temperature of 1090 degrees Celsius. Using a hammer weighing 1,600 kilograms, the heated steel is forged to give the knife its rough shape. This process includes forming the bolster, which is a typical feature of a forged knife and helps improve balance. Deburring, cutting out the knife. After the initial forging process, the knife blanks undergo deburring, where any excess material or rough edges are removed. This step is crucial to make a clean and smooth finish. A press is used to carefully cut out the knife shape, resulting in precise and well-defined blades ready for further processing. Perforation. Perforations are made in the tang of Felix knives where the handle will be attached later. These perforations serve a functional purpose by providing a secure connection between the blade and handle, ensuring stability and durability in the final assembled knife. Hardening process. The hardening process is crucial for the quality of the blade and its sharpness. It consists of 3 steps. Heating the knife blank. The blades are heated up to a temperature of 1050 degrees Celsius. Following the heating process, the knife blank is subjected to oil hardening. It is immersed in an oil bath, where the rapid cooling of the steel occurs. This quenching process enhances the hardness and durability of the blade, imparting the necessary strength and resilience for its intended use. Ice hardening. The next step involves deep freezing the blades at a temperature of -80 degrees Celsius. This entire hardening process ensures a very fine steel structure and results in a strong yet flexible blade. Straightening. The straightness of the blade is inspected, and any irregularities are corrected to ensure a perfectly aligned blade. Grind the blade. The blade undergoes a grinding process where it is carefully shaped and sharpened. This involves removing excess material, refining the edge, and achieving the desired thickness. Grinding the back. The back or spine of the blade is also ground, either by hand or machine. This step involves removing any rough edges, achieving a smooth and even surface, and ensuring that the back of the blade complements the overall design and functionality of the knife. Drying. After various grinding processes, the blades are carefully dried to remove any moisture or residue. This ensures that the blades are clean, free from contaminants, and ready for further processing. Pre-grinding the bolster. The bolster, a distinct feature of forged knives, undergoes a pre-grinding process. This involves shaping and refining the bolster area to ensure a precise fit between the blade and the handle. Pre-grinding the bolster contributes to the knife's overall balance, stability, and ergonomic design. Pleiston. Fine grinding the blade. This stage involves a meticulous and detailed fine grinding process. Highly skilled craftsmen use specialized tools and techniques to achieve a fine satin-like finish on the blade surface. This not only enhances the knife's appearance, but also provides corrosion resistance and a smooth cutting experience. Cleaning. Cleaning is an essential step in the manufacturing process. The blades are thoroughly cleaned to remove any debris, oils, or residues accumulated during previous stages. This ensures that the knives meet hygiene standards and are ready for the next steps. Riden. Assembling the handles. The handles are assembled onto the blades in this phase. Depending on the design, handles made of different materials such as wood or plastic are attached securely to the tang of the blade. This process may involve riveting or other fastening techniques to ensure a durable and stable handle connection. Asmahan. Finishing of the handles by hand. Skilled craftsmen carefully finish the handles by hand, paying attention to every detail. They smoothen, polish, and refine the handles to ensure a comfortable grip, ergonomic shape, and aesthetic appeal. This hand finishing process adds a personal touch to each knife and ensures the handles meet the highest quality standards. Cleaning and in-process inspection. Once the handles are attached and finished, the knives undergo another round of cleaning to remove any residues or marks. Additionally, in-process inspections are conducted to verify the quality of each knife. Abzian. Sharpening the cutting edge on the grinding stone. The final cutting edge of the blade is sharpened using a specialized grinding stone. Highly skilled craftsmen carefully sharpen and refine the edge to ensure optimal sharpness, precision, and cutting performance. The angle and quality of the cutting edge are crucial for achieving superior cutting results. Cutting inspection. Each knife undergoes a thorough cutting inspection to evaluate its performance and functionality. Packaging and end inspection. Once the knives have passed all quality checks, they are carefully packaged for distribution. The packaging is designed to protect the knives during transportation and storage. Creating super hard knife begins with cutting a steel billet to form the desired knife shape. The next stage involves forging the billet using a hydraulic hammer, which applies intense pressure to shape and refine the metal. After the initial forging using a hydraulic hammer, hand forging techniques come into play to further refine the knife and achieve greater precision and control over its shape and details. Hand forging allows the bladesmith to apply their expertise and craftsmanship to shape the knife with careful attention to detail. Once the basic shape is achieved, excess material is carefully removed, refining the knife's outline. Following this, the knife undergoes a sharpening process, which includes honing the back, the blade, and the body. To achieve exceptional hardness, the choice of steel is vital. The final hardness is achieved through a heat treatment process, which involves heating the blade to a specific temperature and then rapidly cooling it to harden the metal. Making a knife out of a coil spring begins by heating the coil spring to a high temperature using a forge. Then use a cutter to carefully cut a piece of the spring that is suitable for making a knife. With the cut piece of the spring, use a hammer or an anvil to straighten and flatten the metal. Heat the cut and straightened piece of the spring once again and then forge it with a hammer on an anvil. This process helps to shape the metal into the desired knife shape. Ensure to strike the metal evenly to maintain the desired thickness and shape. After the initial forging with a hammer, further refine the knife shape and details using hand forging techniques. Employ hammers, tongs, and anvils to carefully manipulate the heated metal and achieve the desired design. Grinding is essential for refining the shape, thickness, and edge geometry of the knife. Heat the knife to a critical temperature and then quickly quench it in water to harden the metal. This step contributes to enhancing the knife's hardness and overall strength. Straighten the knife if any warping occurred during the heat treatment process. Attach a wooden handle securely to the tang of the knife using rivets. Finally, thoroughly test the knife for its cutting ability and overall performance. To make the knife face strong and enhance its overall durability, heat treatment is a crucial step. The heat treatment process involves subjecting the blade to specific heating and cooling cycles to achieve desired hardness and toughness. The blade is heated to a critical temperature and then rapidly quenched, which results in a hardened state. This hardening process strengthens the blade, making it resistant to wear, chipping, and deformation. After quenching, the blade may undergo tempering, where it is reheated to a lower temperature and then slowly cooled to enhance its toughness while maintaining hardness. This combination of hardness and toughness ensures that the knife face remains strong and capable of withstanding the demands of cutting tasks.